Louis Pasteur, a life devoted to science and humanity. Louis Pasteur, born on December 27, 1822, in Dole, France, is one of the most celebrated figures in the history of science. His groundbreaking work in microbiology and immunology revolutionized our understanding of disease and led to numerous innovations in medicine, agriculture, and industry. This comprehensive biography delves into the life, discoveries, and enduring legacy of Louis Pasteur, spanning approximately 2,000 words. Early life and education. Louis Pasteur's early years were marked by a deep connection to nature and a fascination with literature. Raised in the picturesque town of Arbois in the Jura region of France, he grew up surrounded by the stunning landscapes of vineyards and forests. These natural surroundings would later influence his scientific observations and experiments. Pasteur's love for science and learning began at a young age. He attended primary school in Arbois and showed a remarkable aptitude for mathematics. His father, a tanner, believed in the value of education and sent him to the College Royal in Besançon for his secondary education. It was here that Pasteur's talent for science and his dedication to rigorous study became apparent. Early scientific pursuits. After completing his secondary education, Pasteur attended the Royal College of Besançon and later the École Normale Supérieure in Paris. He focused on the fields of physics and chemistry, but his interest in science extended beyond the classroom. Pasteur conducted his own experiments and observations, displaying an inquisitive mind and a passion for discovery. Pasteur's crystallography discoveries. One of Pasteur's early scientific achievements was in the field of crystallography. He conducted groundbreaking research on the optical properties of crystals, particularly tartaric acid. His work in this area led to the discovery of molecular asymmetry and the concept of handedness in molecules, which had profound implications for the study of chemistry and biochemistry. The revolution in microbiology. Pasteur's career took a significant turn when he began to focus on microbiology, a field that was still in its infancy during the mid-19th century. At the time, the prevailing belief was in spontaneous generation, the idea that living organisms could arise spontaneously from non-living matter. Pasteur was determined to challenge this notion through rigorous scientific experimentation. The swan neck flask experiment. In one of his most famous experiments, Pasteur designed swan-necked flasks that allowed air to enter but prevented dust and microorganisms from reaching the broth inside. He boiled the broth in these flasks to sterilize it and observed that no microbial growth occurred, even though the broth was exposed to air. This experiment conclusively disproved the idea of spontaneous generation and provided evidence for the existence of microorganisms in the air. Fermentation and germ theory. Pasteur's research on microbiology led to a profound understanding of the role of microorganisms in fermentation. He discovered that fermentation was a biological process caused by living microorganisms, such as yeast and bacteria. This insight had far-reaching implications for various industries, including brewing and winemaking, as well as for the emerging field of microbiology. Pioneering pasteurization. One of Pasteur's most practical contributions to science and public health was the invention of pasteurization. He developed a process in which liquid, such as wine and milk, was heated to a specific temperature to kill harmful microorganisms without affecting the product's taste and quality. Pasteurization revolutionized the dairy industry and made milk safer to consume. The silkworm crisis and vaccination. Pasteur's scientific acumen extended beyond microbiology. In the 1860s, the French silk industry was facing a crisis due to a disease called pébrine, which affected silkworms. Pasteur investigated the cause of the disease and discovered it was caused by a microorganism. He developed a method to raise disease-resistant silkworms, saving the French silk industry from significant losses. The development of vaccines. Building on his success with the silkworms, Pasteur turned his attention to human diseases. He developed vaccines for several diseases, including anthrax and rabies. His work on rabies vaccination, which involved attenuating the virus while retaining its immunogenicity, remains one of his most celebrated achievements. Pasteur's rabies vaccine saved countless lives and laid the foundation for modern vaccine development. In 1888, Pasteur's contributions to science and public health were officially recognized when the Pasteur Institute was founded in Paris. This institution was dedicated to the study of infectious diseases and the development of vaccines and treatments. Pasteur served as the institute's director until his death and continued his research into the later years of his life. The legacy of Pasteur's germ theory. Louis Pasteur's germ theory of disease revolutionized our understanding of infectious diseases. It paved the way for advances in microbiology, immunology, and the development of vaccines and antibiotics, saving countless lives. His work fundamentally changed the practice of medicine, emphasizing the importance of hygiene and sterilization in healthcare settings. The Nobel Prize in Physiology or Medicine. In 1903, shortly before his death, Pasteur was awarded the Nobel Prize in Physiology or Medicine for his contributions to immunology and the development of vaccines. This recognition underscored the profound impact of his work on science and medicine. Personal life and later years. Pasteur married Marie Laurent in 1849, and the couple had 5 children. Throughout his life, Pasteur faced various health challenges, including several strokes in his later years. Despite these setbacks, he remained dedicated to his work and scientific pursuits. Louis Pasteur passed away on September 28, 1895, in Marnes-la-Coquette, France. His death marked the end of an era in microbiology, but his legacy lived on. The Pasteur Institute and his research continued to influence the fields of microbiology, immunology, and medicine for generations to come. Louis Pasteur's contributions to science and medicine have had a profound and lasting impact. 1. Germ theory of disease. Pasteur's germ theory revolutionized our understanding of infectious diseases. It paved the way for advances in microbiology and the development of vaccines and antibiotics, saving countless lives. 2. Vaccination. Pasteur's work on vaccines laid the foundation for the field of immunology. His pioneering research on rabies vaccination set the standard for vaccine development and remains a testament to the power of science in combating deadly diseases. 3. Pasteurization. Pasteurization, the process he invented to kill harmful microorganisms in food and beverages, has become a standard practice in the food industry, ensuring food safety and prolonging the shelf life of products. 4. The Pasteur Institute. The establishment of the Pasteur Institute in Paris and its numerous branches worldwide continues to advance research in infectious diseases, immunology, and public health. 5. Scientific method. Pasteur's meticulous approach to scientific inquiry and experimentation set a high standard for scientific methodology, emphasizing the importance of rigorous research and empirical evidence. Louis Pasteur's life and work are a testament to the enduring power of scientific inquiry and innovation. His pioneering research in microbiology, immunology, and food safety revolution. IZED medicine and public health. Pasteur's dedication to finding practical solutions to pressing problems, along with his unwavering commitment to the pursuit of knowledge, continue to inspire scientists and researchers worldwide. His legacy endures as a testament to the power of scientific discovery in improving the human condition.